different heads in centrifugal pump. Now, the first important head in centrifugal pump is the static head. It is HST. Now, it is the vertical distance between water levels in the sump and in the reservoir. So that height we call as static head. Now, this HST having two heads, one is HS plus HD. Okay, so HS is called suction head, HD is called delivery head. Okay, now suction head is the height of center line of the pump above the sump level. It is the height of center line of the pump to the sump level. And delivery head is the height of the liquid level in the tank or reservoir above the center line of the pump. Now you can see this diagram. So you can see in this diagram, now this is the sump level, okay, and this is the tank or reservoir level. This is the center line. This is the center line of the pump. So you can see here, this is HS suction head. So the height above the sump level to the central axis of the pump, that is HS. Then this is HD. This is HD, the height from the center of the pump to the level of water in the reservoir. So that is HD. Okay, so the sum of these two is HST. So that we call as static head. So this is static head. Okay, then the second head in the centrifugal pump is the total head. Now it is the head which has to be developed by the pump to deliver the water from the sump into the tank. Okay, so this is the head which has to be developed by the pump to deliver the water from the sump to the tank or reservoir. So that is my total head. So apart from producing the static head, so this includes the static head. So apart from producing the static head, a pump has also to overcome the losses in the pipe. So plus losses in the pipe and the loss due to kinetic energy at the outlet. Due to kinetic energy at the outlet. So that becomes my total head H. Okay, so you can see this is equal to HST. Now the losses in the suction pipe, that is the frictional loss. Okay, I can write it as HFS, frictional loss in suction pipe, plus HFD, frictional loss in delivery pipe, plus the loss due to kinetic energy at the outlet, that I can write as VD square divided by 2G. Okay, so this is my total head H. Now you can see in this diagram, So this head includes the static head. This is my static head plus frictional loss in the suction pipe, that is this one, friction loss in the delivery pipe, that is this one, plus the kinetic head along the delivery side. So this total height becomes my head edge, that is called total head. Okay. Now in this head, losses in the casing and the impeller are not taken into account. Okay. So that head, that losses, we are not taking into account into the total head. Now this total head, the other names are the gross head. This is also called gross head or effective head. This is also called dynamic head. Okay, so these are the various names for total head. Then next head in centrifugal pump is the manometric head. So it is not possible to measure the exactly losses in the pump casing. So it is very difficult to measure the losses in the casing of the pump. So a term that is known as manometric head is introduced. So it is the rise in pressure energy of the liquid in the impeller of the pump. So you can say it is the rise in pressure energy of the liquid in the impeller of the pump. So that is my manometric head. So to measure this, you can say that if two pressure gauges are installed, one on the suction side, okay, and another one is on the delivery side, okay, that is near to the pump, near to the pump, you can say. Now, the difference in readings of these two pressure gauges gives us the manometric head. Okay, if you install two different pressure gauges, one on the suction side, one on the delivery side, close to the pump, and the difference of reading of these two pressure gauges gives us the manometric head. So if I write this manometric head as HM, so this I should write equal to HMD minus HMS. Okay. Now HMS is my reading on the pressure gauge on suction side, and HMD is my reading on the pressure gauge on delivery side. Okay, so difference of these two readings gives me the manometric head. Now I want to see what is the formula for this, what are the various heads included in this manometric head. So for that, now I apply the Bernoulli's theorem. So Bernoulli's theorem, so first I apply the Bernoulli's theorem or Bernoulli's equation at point B. Okay, so you can see here I have a point B over here. Okay, now this point B is on suction side, that is near to the eye of the pump, near to the eye of the pump. So I apply Bernoulli's equation at point B, and at point A. Point A is on the sump level. Okay, so now I try to apply the Bernoulli's theorem or Bernoulli's equation at point B and A. Okay, so when I write this at point B, I have a pressure gauge giving me a reading of HMS. Okay, so I write my pressure head as HMS plus HS, the suction head, that is my bottom head, plus Vs square divided by 2G, okay, plus the losses in the suction pipe is equal to the pressure head at point A So at point A, the pressure is atmospheric. So the pressure head corresponding to atmospheric pressure is PA divided by rho G. So this is my datum. So datum head is 0. So the dimension of my sump is very, very large. So its velocity in the direction moving down for level A is almost 0. So I can write that velocity head as 0. Okay. Now I again apply the Bernoulli's equation at point B dash. Okay. B dash and point C. Now my point B dash is on now the delivery side of the pump. That is here my point B dash. Okay. So at B dash, my pressure gauge reading is HMD. Okay. And my point C, that is the reservoir or tank level. So this is my section C, point C. So at these two levels, B dash and C, I apply again the Bernoulli's theorem. So now I can write the pressure head at point B dash, that is HMD, plus the velocity head, VD square divided by 2G, plus the datum head. So that is the datum line. So along B dash, I can consider the line as the datum line. So that is 0 equal to now the pressure at section C, that is again atmospheric pressure. So I can write it as PA divided by rho G. Okay. Plus velocity head, I can write VD square divided by 2G plus delivery head HD plus losses in the delivery pipe, frictional losses HFD. So say this is my equation number 1 and this is my equation number 2. Now I subtract equation 1 from equation 2, then I can write HMD minus HMS. Okay, HMD minus HMS. So that comes out to be HS plus HD plus HFS plus HFD plus Vs square divided by 2G. Okay, so then my manometric head is equal to static head HS plus HD plus total frictional head HFS plus HFD and plus Vd square divided by 2G. Okay, so when you see again the diagram, so my manometric head is static head. Okay, then HFD, then HFS. Okay, then Vs square divided by 2G. So this is my total manometric head HM. Okay, so this is the manometric head. Now the total head. Okay, now you can see the total head, the formula for total head, and the formula for manometric head. Okay, so this is the formula for total head. Okay, and this is the formula for manometric head. So now you can see the difference between these two. Now the difference is in the velocity head. So you can say in total head, we have the velocity head corresponding to the delivery, the velocity in the delivery pipe, that is Vd. Okay. However, the manometric head contains the velocity head as this is Vs. This is Vs. So manometric head contains the velocity head corresponding to the velocity in the suction pipe. So here is the velocity. So here is the difference is in the velocity head only. Okay. So you can say my H is equal to HM if Vs is equal to Vd. Okay. So you can see here. So it is to be noted here that H is total increase in energy of the liquid by the pump, whereas HM is the gain in pressure energy only. H is the gain in total energy plus the HM is the gain in pressure energy only. Okay. The difference between these two is very, very negligible. ठीक है. So you can say the both are synonymous to each other. Or in other ways, you can say if the diameters of the pipe, suction pipe as well as the delivery pipe is same, then we have Vs is equal to Vd. So in that case, my total head is equal to the manometric head. Okay. So the both terms H and Hm are synonymous to each other.